November 12th, 1942. 0615 hours. The sand north of Casablanca is still cold. An American sergeant from the 1st Infantry Division crouches behind a low stone wall, gripping a Thompson submachine gun that weighs nearly 11 pounds loaded. Across the road, a French Vichy position opens fire. He raises the Thompson, squeezes the trigger, and in 2 short bursts empties a 20-round magazine into the wall and window ahead. Dust and stone chips erupt across the facade. The recoil is heavy but controllable. Return fire stops. That sergeant is carrying a weapon that cost the United States Army $209 per unit in 1942. Adjusted for inflation, that is roughly $3,700 today. The British Sten gun, doing the same job across North Africa that same month, cost approximately $11 to manufacture. The Soviet PPSh-41 cost even less. The German MP-40 sat somewhere in the middle. This is the story of the Thompson submachine gun and why the truth is more complex than the legend. The Thompson has one of the most persistent reputations in all of World War II small arms history. It is the gun of Hollywood, the weapon of Normandy footage, the submachine gun that every collector wants and every documentary features. And the conventional belief is simple. The Thompson was the best submachine gun of the war. Superior stopping power, built like a precision instrument. Worth every cent. That is the myth, and it is not entirely wrong, but it hides a far more uncomfortable question. When you are fighting a global war on 2 fronts, producing millions of weapons under extreme time pressure, is the best weapon actually the right weapon? Was the Thompson worth 5 times, 10 times, or even 20 times the cost of its rivals? Or did America's obsession with quality nearly become a strategic liability? If you are finding this interesting, hit subscribe. More deep dives like this are coming. To understand why the Thompson cost what it cost, you have to understand what it actually was. The Thompson was designed by General John Taliaferro Thompson in 1917, originally intended for trench warfare in World War I. The war ended before the weapon saw combat. Ordnance Corporation, the company Thompson founded, spent the 1920s trying to sell it commercially. It gained notoriety in the hands of Prohibition-era gangsters, which gave it the nickname Tommy Gun, but military sales were slow. The original Thompson, the M1928A1 variant, was machined from solid steel billets. The receiver alone required over 40 individual machining operations. The weapon used a delayed blowback system based on a principle called the Blish lock, a bronze H-piece that theoretically slowed the bolt's rearward travel during firing. Every single Thompson required precision machining that most firearms of the era did not demand. Production time per unit was dramatically higher than any competing submachine gun, which means the cost was not an accident or a markup. It was built into the weapon's DNA from the very first blueprint. The M1 variant, introduced in 1942, simplified the design significantly. The compensator was removed. The barrel fins were eliminated. The Blish lock mechanism was replaced with a simple blowback system. The charging handle moved to the right side. These changes reduced the manufacturing time from approximately 17 hours per weapon to roughly half that. But even the simplified M1 Thompson still required extensive machining. The receiver was still milled from steel. The tolerances were still tight. Compare this to the Sten gun. The Sten was made primarily from stamped sheet metal and welded tube. It required minimal machining. A single Sten could be produced in roughly 5 hours of total labor by semi-skilled workers, many of them women who had never touched a firearm before the war. The PPSh-41 used a similar stamped construction philosophy, with a chrome-lined barrel that was often salvaged from old Mosin-Nagant rifle barrels. Soviet factories, many of them relocated east of the Urals under German bombardment, could produce a PPSh-41 in roughly 7 to 8 hours. Even the German MP-40, despite its reputation for engineering complexity, used more stamped components than the Thompson and required fewer precision machining steps. The Thompson M1 required roughly 9 to 10 hours of skilled labor even after simplification, and that word, skilled, matters enormously. Stamped weapons could be built by trained factory workers. Machined weapons required machinists. In wartime America, every skilled machinist building Thompsons was a machinist not building aircraft engine components or naval gun mounts, which means that for every Thompson produced, Britain could manufacture nearly 2 Sten guns, which means the production bottleneck was not just about money. It was about time, labor, and machine tool allocation during a war where all three were desperately scarce. And here is where it gets interesting. The Thompson's cost was not simply about the weapon itself. It was about what economists call opportunity cost. Every hour a skilled machinist spent cutting a Thompson receiver was an hour not spent producing something else. Every milling machine dedicated to Thompson production was a machine unavailable for other war material. The $209 price tag was only the visible cost. The invisible cost was far higher. Now the defenders of the Thompson have a case, and it deserves to be heard on its merits, and the evidence is not trivial. July 10, 1943. Sicily. The 1st Infantry Division lands at Gela under heavy counterattack from the Hermann Göring Division. American infantry armed with Thompsons engage German troops in the narrow streets of the coastal town. The engagement ranges are under 30 yards. Soldiers later reported that the Thompson's heavy .45 caliber rounds produced an immediate stopping effect at that distance. Targets went down fast. The 9mm rounds fired by captured MP-40s did not produce the same visible result. The .45 ACP round weighs approximately 15 grams and travels at roughly 260 meters per second. The 9mm parabellum is lighter and faster. In raw kinetic energy, the two rounds are closer than most people assume, but the .45 transfers its energy differently. The heavier, slower bullet deposits momentum into tissue over a wider area rather than punching through, which means in close quarters combat, the Thompson created more immediate incapacitation, and soldiers could see that difference with their own eyes. During the fighting in the Hurtgen Forest in late 1944, American infantry units operating in dense woodland confirmed what the Sicily veterans already knew. The Thompson's stopping power was devastating at close range. The heavy, slow-moving bullet transferred energy into soft tissue more effectively than the 9mm parabellum rounds used by the MP-40 and Sten. Soldiers clearing bunkers and fighting through thick undergrowth valued the stopping power. One after-action report from the 4th Infantry Division noted that soldiers armed with Thompsons in house-to-house fighting near Aachen expressed strong preference for the weapon over the M1 carbine, at distances under 50 yards. In the Pacific Theater, the Thompson found another natural environment. Jungle fighting in Guadalcanal, Bougainville, and the Philippines placed engagements at ranges where the Thompson's controllability and stopping power were genuine advantages. Marines in particular developed a deep attachment to the weapon. During the fighting on Peleliu in September 1944, Marine units that still had Thompsons resisted attempts to replace them with the newer M3 submachine gun. But that resistance itself reveals something important. The M3, nicknamed the grease gun, was America's answer to the production problem. It cost approximately $22 per unit. It fired the same .45 ACP round as the Thompson. It weighed significantly less. It was made almost entirely from stamped metal and could be produced by workers with minimal training. The M3 was not elegant. It was not precise. It rattled and it felt cheap compared to the Thompson's solid machined heft. And soldiers hated it, at least initially. The M3's single-stack magazine was prone to feeding issues when dirty. The cocking mechanism, a finger hole in the bolt, felt awkward. The rate of fire was lower, which some soldiers saw as a disadvantage, and others considered a feature that conserved ammunition. But the core complaint was psychological, not mechanical. Soldiers who had trained with the Thompson trusted it. The M3 felt like a downgrade. This is where the myth diverges from reality. The question is not whether the Thompson was a better weapon than the M3 or the Sten or the PPSh-41 in a vacuum. In many measurable categories it was. More controllable in sustained fire, better stopping power at close range, more durable construction, superior ergonomics. The Thompson felt like a weapon. Its competitors felt like tools. But war is not fought in a vacuum. War is fought with logistics. The United States produced approximately 1.7 million Thompson submachine guns during World War II. That sounds enormous until you realize that the Soviet Union produced approximately 6 million PPSh-41s during the same period. the British produced roughly 4 million Sten guns. Germany manufactured approximately 1.1 million MP40s. Here is the critical question. If the United States had adopted a weapon with production characteristics closer to the Sten or PPSh-41, using comparable industrial capacity, output could have been meaningfully higher. Estimates vary, but even conservative calculations suggest hundreds of thousands of additional submachine guns that could have reached soldiers who instead carried M1 carbines, or in some cases, no automatic weapon at all. Now, this calculation is imperfect and deserves honest qualification. American industrial capacity was not a simple input-output equation. Machine tools allocated to Thompson production were not necessarily interchangeable with stamping presses needed for Sten-style weapons. Retooling would have cost time. American logistics and doctrine were built around the specific weapons already in production. Changing mid-war carried its own enormous risks. And there is one factor that statistical analysis consistently undervalues: soldier confidence. A Marine on Peleliu who trusted his Thompson fought differently than a Marine carrying a weapon he considered unreliable. Morale is not a line item in a procurement spreadsheet, but it is won and lost engagements throughout history. The Rangers at Pointe du Hoc on D-Day carried Thompsons by choice. The paratroopers of the 82nd Airborne who jumped into Normandy trusted their Thompsons with their lives. That trust was earned through months of training with a weapon that never let them down. You cannot manufacture that confidence cheaply. The competing evidence is real. The Thompson was genuinely excellent at what it did. Soldiers who carried it fought with measurable confidence. The .45 ACP round was genuinely more effective at close range than 9mm alternatives in soft tissue impact. The weapon's durability in field conditions was exceptional. But the uncomfortable truth is this: excellence in individual weapon performance does not automatically translate to strategic advantage. The Soviet Union understood this instinctively. The PPSh-41 was not the best submachine gun of the war by any individual metric. It was the most strategically effective submachine gun of the war because it could be manufactured in quantities that matched Soviet doctrine. Entire battalions could be armed with PPSh-41s. The weapon became the doctrine. The doctrine became the weapon. The Thompson, for all its quality, could never achieve that kind of strategic saturation. It remained a specialist tool in an army that needed a universal solution. And by 1944, the United States military acknowledged this reality by introducing the M3 as its standard submachine gun, effectively admitting that the Thompson's cost was unsustainable. The evidence tells a different story than the one Hollywood wrote. The Thompson was the finest submachine gun of World War II that almost no army could afford to build in sufficient numbers. It was a peacetime weapon designed for precision, forced into a wartime role that demanded scale. It was the engineering equivalent of writing every letter by hand when the war required a printing press. November 12, 1942, that sergeant north of Casablanca finishes his engagement. The Thompson performed exactly as designed: controllable, powerful, reliable. He survived because of that weapon. But somewhere in a British factory, in the same hours it took to machine one Thompson receiver, 2 Sten guns rolled off the line and shipped to 2 soldiers who otherwise would have carried nothing. That is the lesson of the Thompson. The best weapon is not always the right weapon. And 8 decades later, the question still has no clean answer. How much excellence can you afford when the war demands enough?